Welcome back once again, friends. We shall continue our journey into the world of Python by looking at an extremely important logical construct called the if-else statement. Now, this is a kind of like a universal programming construct. We have seen this previously, for example, in Scratch. In this video, we'll look at it, for example, in Python. Of course, we'll do all our discussion in context of the activity that we had been developing, which was this Prof's Grumpy Assistant. Remember, previously, our assistant had asked us a question, which was, please tell me what action words are called in English. And we have stored our response in this in this variable called answer, right? So now we want to move further from here, and we want for example, the assistant to decide whether we have answered this question correctly or not. Now basically, whenever a decision of this sort comes in, if else statement becomes a useful one, right? So let's just first put this code together and see how we do this in Python. What are the important parts of it, and what are some things that we have to be careful about. So I'm just going to start writing this code for now. So I'm going to say if answer dot lower, remember I must have these two brackets in the end in order to get the lower case of the answer that I've provided, double equals to, say, VERBS, right? Now I'm going to put a colon here. We'll talk about all of this later. I'm going to say print. Remember, I basically answered correctly, but then this assistant is not so easy to please. So he just says, okay, correct. But that was only a warm up, right? So that was only a warm up. So he's not very pleased with it, but nevertheless. However, if we get it wrong, for example, which means I go into the else, then the assistant is quite like nasty and just says let's say your chances of meeting the prof are very low, right? Now again, this is just part of the story we have, but the important bit here is to try and understand what does this if else statement do. So we can just actually first test this. If I run this code, for example, right now, let's say tell me what action words are called. So first I'm going to answer correctly. Let's say I answer verbs. Remember, I can answer with a capital V because I have got this answer dot lower with the brackets over here, right? So it's going to convert that to small letters and then compare. So if I do that and it says correct, but there is only a warm up. On the other hand, let's say I do it again, and what are action words called? Let's say I answer nouns, right? So which is obviously incorrect, and our assistant also figures out that it is incorrect, so it goes into the else, and then it says, I think your chances of beating the prof are very, very low, right? Now let us spend some time looking at this loop very carefully. There are 6 points that I want to make here, right? The first point is the basic structure of this loop, right? Which is that if logical condition, then the if statements, else, then the else statements, right? So the first thing I would want you to realize is that this statement, in fact, is exactly the same as the if then else statement from Scratch, right? We had used this in the quiz. I've also pulled it out here as a, let's say, as a separate entity. We are doing exactly the same thing, right? Which also means that just like earlier, I told you if then else junction, if then else statement is basically a T junction, right? So the execution comes until here. At this point, it makes a decision. Should I go to the if side or should I go to the else side, right? So first point is that this if then else, this if else is in fact exactly the same as what happens in Scratch, which means that the code is going to come until here. At this point, there'll be a decision, right? Either I go into the if statements or I go into the else statement. So I can't be doing both of them together, right? So that's like point number one. Yeah. Next, let's look at this statement itself, right? So we have got if, let's say, a logical condition, then so there's no then here, but basically if logical condition, right? Now logical conditions, what are these, right? Well, these are the conditions, these are the sort of judgment points based on which we decide whether we are saying we are going to do the if part or we are going to do the else part, right? Now again, let's go back and sort of okay, so remember from Scratch, we had a bunch of logical conditions in Scratch, right? So for example, we had, this three basic conditions: greater than, less than, and equal to, right? Of course, here we could put numbers. We could also put like names, in which case it's strings essentially. And then we could build on these, these basic conditions using the and, or, and not. Now, turns out that in Python, in fact, in any logical language, any programming language, in fact, there will be equivalent conditions. So Python conditions are exactly equivalent. We have the equivalence between the greater than, less than, and equal to. However, a few things to note. Okay, number one, that in this equal to condition, whenever I'm checking for equality, right, I must put double equal to. So this statement here, something equal to 50 for instance, will be written as, for example, a equal to b, or equal to 50. In addition, we also have two conditions, which is called greater than equal to and less than equal to. What this means is that the number can be greater than or equal to the other one, right? And then this becomes true. Apart from that, we can also do the and or, just like these two blocks. We can also do that in Python. Syntax is very simple, and or respectively. And the not is given by this exclamation mark, right? So these are something, again, don't have to memorize them, but with practice, you just become more and more comfortable, right? So remember, I told you the logical condition for equality is always two equal to signs. And in fact, we can see that that's exactly what I've done here, right? You can try here, if I, let's say, removed one of the equal to's, right? In fact, the interpreter gives us an error right away. So if I run this, I'm going to get an error in my syntax error, right? Because I've got a if condition. Then if I'm checking for equality, right? If I'm checking for equality, I must put two equal to signs, right? So that's sort of like uh, within the logical conditions, right? So first point itself was the logical condition. The second point is how do we express this? The interesting bit is that checking for equality requires us to put two equal to marks, right? Now here we could have a number, we could have a variable. If this side could be a number, that's okay, just like scratch. But no matter what, when we're checking for equality, we must put this equal to sign. I mean, this double equal to sign. Next, we have the colon. Right now, this is a part of the syntax. Again, you can try removing this. You are going to get a syntax error, right? So if you did that, you're going to get a syntax error because it was expecting a colon over there. Basically, this is telling that the logical condition has now ended. And likewise, you need a colon over here at the else position. So this was point number 4 for me. So first point was the structure of the loop. Second point is logical condition. Third point, this equalities in the double equal to. Fourth point, this colon. Notice we also need a colon in the else section. So in a way, you can think of this colon as the then of this. So remember, it was if condition then else. Of course, there's nothing here, but it's kind of understood, right? So the colon is acting like that then part, right? So and this is part of the syntax. We have to put this, right? If you don't put this, you get a syntax error. Number 5, and quite interestingly, notice here that I have offset my print statement from the if statement. So what I mean by that is that if I just see vertically down, I have given a gap here of a single tab, right? In fact, if you do this, you will automatically get a gap because this editor is smart enough to realize that that gap is needed there. Now what exactly is that gap? I have done the same gap here, same this thing here on the else. Now this is called indentation, right? Indentation means providing a tab, providing a space, because in Python statements are logically arranged by indentation. Right now, remember previous lesson, one of the earlier lessons, I've told you that you can give as many gaps as you want to, but I cautioned you against giving spaces in this direction, right? That's because, as I told you, these spaces constitute indentation, and what it means is that now in this particular statement, this anything that is at this indentation level is basically inside this if. Anything that is at this indentation level is inside the else, right? And this is very important. Again, you can try not to indent and you are going to get an error over here, right? So if I run this now, you're going to get an indentation error, right? So it's expected an indented block because you have used an if statement, right? Now this is in fact an extremely important and I would say a defining point for Python, because this indentation is how we logically arrange pieces of code. Right now we are seeing it for the if else statement. We are going to see the same thing, for example, for the for loop, for the while condition, and so on and so forth, right? So indentation is actually extremely important in Python, right? Finally, notice that in this statement, right, in this statement, in fact, the syntax is really, really clean. Uh, this is more apparent to those who have come from different, let's say, different programming languages background, for example, from C or say some other languages. You notice that in most of those languages, we have to put brackets to, around the, let's say, around these logical conditions. We also sometimes have to put bracket to demarcate the if part, demarcate the else part. On the other hand, over here, there are absolutely no brackets, right? Now, you might wonder, why did I say there are no brackets when there are indeed brackets on the lower, there are indeed brackets on the print, but these are, remember, for a different purpose, right? Remember, we have spoken about this answer.lower with brackets means that this particular method must be implemented for this condition to be checked, right? So that's not the if condition bracket. That's really that's really, let's say, the bracket induced by the function, the method that we are using. Similarly, print brackets are for the print statement, right? But for the if else itself, we can really have a very simple statement. Let's say I can give you an example. For example, let's say a equals to 10, b equals to 20, and I can have a statement if, let's say, a is greater than b. Remember, I must have a colon. It indents by itself. I can say print, let's say hello. I mean, I'm just doing something here, and I can then say else, say print, maybe by. I'm again doing just something to illustrate, right? But notice how clean this syntax is, right? How this uncluttered. This is reads almost like English, and that's why Python is known to have a clean syntax, which obviously we must maintain. It's due to do with the fact of the indentation and use of less brackets, right? Which just makes it much cleaner, right? Now, talking of indentation and talking of, let's say how this code is structured, a question that comes up, and I think that's kind of important to highlight, is how do I know where does this loop end, right? Now, this question may look trivial, but think about it, right? Over here, I've got statements for the else, right? So this was the if part. Now this is the else part. How do I know that this statements, where do they get over, right? In fact, the answer is already mentioned. You would have guessed it if you are hearing this carefully. The answer has to do with indentation, right? So I'm going to give you two scenarios here. Let's say in first case, I go and print an empty line. And I also, because I'm going to build this game further, I unindent and I ask my next question, let's say, so that I can highlight this. So I can go and say, let's say sentence, or say, I'm going to say word is equal to, input, uh, give me an eight letter English word with at with at least three vowels, right? So this will be the next question. We talk about this separately, but the point I'm trying to make is that I have two situations here. One situation, I'm putting this print here, this print over here with an indentation. Notice I've given an indentation here, and in another case here, I'm putting it without an indentation, right? So let's see what's the difference between these two. First, let's look at this case when I do not put an indentation. Let's say what happens here, right? Remember, I told you that in this situation, once the indentation is over, in fact, the loop is over, which means that the print statement is really outside the loop, right? So remember, I can put as many blank spaces, doesn't matter, but really I have brought this outside the loop, right? So what has happened now is that if I answer this correctly, I will get a line, between, I get an empty line between my answer and the next question, and we can see that happen right now, right? So if I do this, let's say, so I answer, let's say verbs, which is the right answer. Notice it prints this correct. That was only a warm up. It puts an extra line and then it asks me this question, right? On the other hand, let's say now I indented this statement, right? So let's say I indented this statement. Remember, the moment I indent this, in fact, they have come into same logical, let's say, placement as the else part. This blank statement is not going to matter. So what's going to happen is that if I now run this condition and I answer this question correctly, it asked me the next question, but notice there is no extra line between this and this. That's because the print now is part of the else. And remember, if then else was a T junction. The moment I answered this correctly, I entered the if part and I exited the loop, which means I came directly to this statement. It asked me a next question, right? Now, to illustrate this, in fact, I found that, it's really interesting to go back and compare this with, let's say, what happens in, say, in Python. I'm sorry, in Scratch. So we had two situations. Case one was no indentation. In fact, you can visualize this as, in Scratch, as though the print statement was outside the loop. In Scratch, it was very simple. What is inside if, what's inside else, because it's visual. Anything in here is inside else. Right now, by putting this print outside of the indentation, we have effectively created a situation where my code looks like this. So if then else gets over, then the print comes. On the other hand, in second case, I put the indentation, in which case indentation became a part, this print became a part of the else statement. In fact, the code became something like this else statement and print statement, right? So I thought this visualization is quite powerful. In fact, as I was doing this, a student nicely pointed out that the fact of indentation also, probably unintentionally, also gets highlighted here, because in Scratch also, because of the way this thing is built, we end up doing a little bit of indentation here, right? That's just coincidental, but I hope you got the idea, right? I hope you got the idea of how we use the if then else. What are the important bits to remember? Again, Practice is everything. The more you practice, the easier it will get for you. And this is something that will be universal. You're going to use this again and again, no matter what kind of programming you do later. Okay, so take care. I hope you found this useful. Thank you so much. Bye bye.